Hello, everyone. Happy Monday. Happy International Women's Day to all my female students. Wish you a good holiday, happy holiday. Okay. I want to use this video to share with you the discussion number 3. Let me see. Number 4, sorry. Discussion number 4, the new discussion of this week. We are going to explore the temperature in your area, basically. So let me share my screen. All right. So this is in under module 2. This week, we're going to continue this module to understand energy and temperature. Basically, last time I have this lecture presentation. You can see the video is here. I covered everything there. Okay, so we are going to continue using this video for this presentation. Okay, if you haven't done this yet, please watch this video. Please watch this video. Okay, all right. So then the next thing is our discussion number 4. Discussion, understand daily and seasonal temperature variation. Okay, so basically you need to watch that video first and then come back to this discussion. Okay, so here I'll go same, summarize what you learned in this week. Okay, and to build the learning communities. So what you're going to learn this week, you're going to learn how the energy transferred in our atmosphere, inside our atmosphere, multiple ways. Multiple ways. In other words, you're going to learn how our atmosphere is heated, is get warmed by the sun and by the earth, by the ground. Okay, so that is a very important thing to know, to learn before you start this discussion. Okay, so there are actually 4 ways, like I listed here. Okay, so first, so in your initial post, you want to pick your location. Okay, for example, I'm in Los Angeles. Okay, in the long term, all these 4 methods, they work in a long time, always. Okay, always. So how does each of the following energy sources get transferred into atmosphere, including shortwave radiation, that is from the sun? You learned that from last week, right? The sun, the surface temperature is very hot, so the radiation from the sun is shortwave, as opposed to our Earth, you and me, right? That is the long wave, the wavelengths of the radiation energy emitted by the Earth, and also you and me. Temperature is low, so the wavelength is low. Okay, long-term, long wave radiation from the Earth, short wave energy from the sun. How those radiation energy get transferred? Okay, in addition to radiation energy, long wave radiation energy, our Earth's ground can also provide the other 2 types of energy. Number 1 is your sensible heat. So what is sensible heat? That is the heat you can feel, right? Sensible, sensible. Or in other words, that is the thermal heat energy, thermal energy. That is, how fast our molecules move. Okay, so for example, if you have a hot object inside the molecules in your hot object, like your coffee or something, the water, they move fast, they move faster. Okay, so when you put the thermometer in your coffee in this hot object, temperature is high. So last time you learned it, temperature is a measurement about how fast your molecules move, right? Okay, so then if you put a hot object with a lot of sensible heat, okay, as thermal energy, to a cold object, the molecules move slow, right? So the heat will transfer from the hot to the cold. Basically, that is speed up the vibration of the molecules in this cold object. Okay, so that is a sensible heat. You need to contact those two objects to transfer those energy. So that is the one way, okay, for our ground to heat up our air, because you have the air touching the ground. When the ground is hot, for example, at noon, our beach, the sand is very hot. So the air touching it is also very hot, right? So that is a sensible heat. The other one is latent heat. Latent heat related to the phase change of our water. Okay, so in lecture presentation in your book, you learn that when the water change from, for example, liquid to gas, evaporation, that happens anytime, right? Every minute, every second, from our ocean, from our lake, from our water rivers, right? Okay, so those evaporation will basically, that is your liquid water that evaporated, become the air, become the gas, sorry, become the water vapor. But in this process, okay, you can see liquid water become gas water. Basically, they keep social distance. I have this metaphor. Basically, the molecules keep away from each other. Okay, so let me give you a phase change. Okay, give me a picture molecules like this one. Okay, like this one. So you can see in a solid phase, they all hook up very, very tightly. Okay, like this here. Okay, so you can see the water in the solid phase, they stay close to each other. Okay, they stay very, very close to each other. But when you in this liquid phase, okay, you can see the distance between your molecules actually get a little bit longer, a little bit further away from each other. Keep social distancing. And in the gas phase, you can see here, they become, even more separated, right? So what is that latent heat energy? Latent heat energy actually is used to keep them away from each other. So you can see here, from liquid to gas, you need energy, right? So we'll put into our context, from our ocean to the air, okay, liquid to gas. They need first, in the first place, they need to absorb the energy from the ocean, right? To keep away from each other, and then they can go become the gas, water vapor, which contains more energy, carry more energy like this, right? But what's happening next? What's going to happen next? That is, in the air, in the sky, they become cloud, right? You see that every day. Then cloud, here, don't get me wrong, don't get this term wrong. Cloud actually is liquid water. It's gas, it's a liquid droplet. Okay, so when you as long as you see cloud, if you want to have a cloud, you want to make the gas water condense back. You want to make the gas water condense back. So you can see in this process, you don't need that much energy, right? So you need to release the energy. So condensation actually release the energy to in the sky, to our air, right? Because those gas, they're in the air and they condense, they become cloud, right? So you can see in this process, let me change our color here. Okay, so you can see when the air, I actually need to switch the color. Sorry, let me switch the color. Okay, so when the liquid water become gas water, okay, they need energy, right? They need energy. Okay, so that is evaporation, absorb energy from Earth's surface, right? So this is the first place. You can see the Earth from the ground, from our surface, the energy get absorbed, taken away, right? Taken away. And when you see the cloud condensation happening. Condensation happening. Let me draw an arrow. Oh, let me change the color. All right. Okay. So the gas water become liquid water, right? Okay. So then you release the energy. So evaporation, condensation, release. Okay. But because your gas is in the air to our atmosphere. So you can see this is how you transfer latent heat, from the ground, from our surface, all the way to the air. Because you absorb the heat from the ground, release that latent heat in the air. Right? Okay, so that is the same. That is this one. Okay, so let me clear my drawings. Let's go back to our discussion. So basically in your area, okay, you need to describe how each of the following energy play a role in terms of heating atmosphere in the long term, naturally, okay? And you want to make sure you describe the transfer processes like what I just described with details. Okay, and you want to challenge your classmates. The second one, to understand the daily temperature variation at your location. Okay, so basically, I want you to go to windy.com, right? Okay, so you can see to record 3-hour average temperature at your location in one day of the week. So for example, let's record today for Los Angeles. Okay, so you can see in Los Angeles, I can record today, International Women's Day. Okay, so you can see that is AM 12 Celsius. You can click on this link to change that to Fahrenheit. Okay, so you can see that is a Fahrenheit. Okay, whatever way you want, but you need to identify, you need to acknowledge let people know which unit you're using. Okay, I'm using Celsius. Okay, or you can use Fahrenheit. Okay, so you can see here, I will record it those temperature. You can see that is 3-hour average. Then I will put it in this table. Okay, in this table, and you need to identify the location, longitude and latitude, location name. Okay, by the way, on windy.com, you can see that here. Oh, sorry, here. All right, here we go. You need to use your mouse, swipe, move that to the left. Okay, so you can see this actually is the location of Los Angeles. And you have the height, I think, altitude, about like 100 meters, 300 feet, 311 feet. Okay, so record your location here. Okay, and that's it. That's for your initial post. And then come back to read to see your classmates there recording in another place. For example, okay, I have a friend. Let's see. Let's go up. For example, Seattle. Okay, I have a friend in Seattle. All right. Okay, so you can see that is their temperature of the day, of the same day, or you can use a different day. Actually, in 1 week, it doesn't matter that much. Okay, and then you want to maybe also acknowledge the location over there. Okay, so you can see here, I want you to compare the temperature tables with yours, between you and your classmates. Okay, by plotting the temperature together. So this is a little bit like a lab, okay, to do. Okay, so you can see, make sure you use the same temperature unit. Okay, Fahrenheit, both Fahrenheit, Celsius, both Celsius. You can compare, right? So if you don't know how to, you can basically manually draw. But if you want to like plot a very nice picture like this one, you're more than welcome to use my template. Okay, that is Excel. So you download it here. Okay, so this is your template. Okay, you can change that if you want to use Celsius. You can change that here. So for example, I change this temperature. I just play with it. Okay, so Celsius, let's say, become 15. And you can see this chart will be changed. Okay, so you can, when you finish, you can just, right click on this chart and then save as picture and then include that in your post. Okay, so play with it. Let me check that back. Never have the 15 Celsius in the morning. Right? Okay, so if you use Fahrenheit, it's right here. Okay, save. Okay, all right. So, but indicate which day you're recording. Okay, indicating which day you're recording. Okay, so let me stop. So that is your second post. Okay, and then you want to explain why those two locations have different temperature, daily temperature variation. So you can see here, I give you an example about Chicago and Los Angeles. The blue one is Los Angeles. We have a higher temperature, and here we have a lower temperature. Well, think about what contributes to your long-term radiation, right? Long wave radiation, short wave sun radiation. Basically, latitude play a role here because Los Angeles, we're close to the equator. Our short wave sun radiation is much stronger, more intense down here compared to Chicago, right? So you can see in general, our temperature in Los Angeles is warmer than Chicago, right? In general, at every hour. But we do have the same trend, right? So when the day, get up, moving on, you can see the temperature first increase and then the temperature drop in both places. Why? Well, your long wave radiation, the earth, the ground get heated up and then in turn heat up the atmosphere, right? That happens every place. It doesn't matter which latitude, which place you're located, it's always like that. Okay, so you can see when the ground got heated up, your air got heated up. And then down in the afternoon, it will go down, right? Because the ground got cold and actually atmosphere in turn start warming our ground. That is in the evening, in the night when the ground doesn't have the solar energy input, you will have the air energy input, right? That is a radiate back. That is transfer back transfer from the heat energy from our air to our ground, right? So you can see that makes sense when you plot it out. Okay, so describe this. Describe this. What make those things different? You may see other things. For example, we have a storm in certain place, right? And that will suddenly decrease your temperature. So you can see, for example, let's see where we have a temperature. We want to find low. Okay, so let me find one. Let's see, Salt Lake City. Yeah, Salt Lake City. Let's see. Yeah, so you can see here they have, like for example, they have rain, they have snow on Tuesday, right? You have very low temperature. You also want to count the impact of our weather. Okay, so in your discussion, you will have maybe more interesting comparison. Okay, all right. So please make sure you post your initial post by this Friday, and response to your peers on Sunday. All right. Okay. So I will hold office hours in the evening, in the afternoon from 2 to 4 p.m. If you have any questions, please come. Okay. And in addition to this assignment, you're going to also, of course, better log, okay, and finish your quiz. Finish your quiz. Okay. All right. So let me change the quiz to Also 14 give you more time. All right. Okay. So that's it. That's it. Okay. Wish you a very happy and productive week. Okay. Bye for now.